Hi guys, welcome back. We are continuing our journey through the alimentary canal, and we are now in the large intestine, the last trip of this foodstuff as it's making its way down the tubes. We went through the stomach and the small intestine, now we're in the large intestine. So here is the diagram showing how the large intestine sits in your abdominal pelvic cavity. I'm not going to talk about a lot of the anatomy. I did want to point out one modification of those layers for you. Where is it? Right here. So this guy right here is called the tenui coli. So if you remember, the muscularis externa has a circular and longitudinal layer, two layers of muscles stacked. In the large intestine, one of those layers, the longitudinal layer, has been reduced into three kind of bands of smooth muscle. So it's not a completely even distribution of those longitudinal muscle fibers. They are in these little bands, and so that's the tenui coli. And what that does when they tense up, it makes the pouch-like shape of your large intestine. Those pouches are called haustra. So it's not a completely strong muscular tube like your esophagus or your stomach or your small intestine with two layers completely around it. The circular layer goes completely around it, but the longitudinal has been reduced into these tenui coli. So when we look on the next slide of the close-up of the histology, we'll see how that's different. So here, our longitudinal layer is a tenui coli. The circular layer is just completely around, even though the picture doesn't make it look that way. But there is our serosa, would be right here. Here's our muscularis externa, I already circled. Here's our submucosa, and then from here up, this is our mucosa. So again, we can see all four of those layers in the large intestine. Now, the large intestine's surface, its apical surface, you can kind of see the little pock marks and pits going down into these glands, and they're primarily mucus glands. You can see they are filled with these goblet cells, mucus cells, we call them goblet cells, but they're going to be secreting a lot of mucus as this undigested, unabsorbable material makes its way to the large intestine. It's going to become solid again. So it's a liquidy chyme, it's liquidy in the small intestines, it's liquidy when it gets into the large intestine, and one of the major jobs of the large intestine is to reabsorb water. And so as this chyme and this undigestible watery slurry gets on down the large intestine, it's reabsorbing water, and what's left over becomes your solid waste, your feces. Okay. Within the large intestine, we have very little nutrient absorption, right? So 90+% of the nutrients already got absorbed in the small intestine. We do absorb a little bit here along these the simple columnar epithelium, but not a ton. They're not made for nutrient absorption. They're made for water reabsorption. We also get some vitamin production and absorption in the large intestine. We have a normal microbiota, a huge population of bacteria that live in our large intestine. And one of their jobs for us, we're in a symbiotic relationship with these bacteria. We give them a nice warm place and lots of food to eat, and then they give us some protection against foreign invaders, but they also make some of our vitamins. So I have, let's see, bacteria produce vitamin K, which is needed for blood clotting. So if you remember back to our hemostasis steps, the intrinsic and extrinsic pathways to get to the common pathway, vitamin K played a part in that. Biotin, which is a vitamin that's important in glucose metabolism, and vitamin B5, which is important in steroid hormone production and some neurotransmitter production. So a good 50% of our vitamin K is produced by the bacteria that live in our large intestine. So we got to treat them right. Some other things that can be absorbed is some of the organic waste material that is produced in the process of digestion, things like bilirubin and ammonia and hydrogen sulfide. A lot of that stays, but some of it minimally can be reabsorbed. And then we do take a look at the product of the large intestine. We can all say it, it's poop, right? Feces, fecal matter, whatever you want to call it. But it's brown, usually. It's smelly, usually. And so those are some characteristics of some prior processes that we have actually taken a look at. So if you remember, way back in 232, we were talking about hemoglobin recycling, red blood cell recycling, right? So the red blood cells circulate and live for about 4 months. When they get broken down, their heme in the hemoglobin gets recycled. The protein bits or the heme gets recycled with the iron back to the bone marrow to make more hemoglobin. But the protein molecule without the heme becomes the bilirubin, and then becomes the biliverdin. And that goes back into the blood supply, and we use some of that to make the bile. We use some of that, the kidney processes some of that, and some of that ends up in your digestive tract, in your large intestine. So the browns and the yellows that you get in your feces is the metabolic breakdown of your hemoglobin, right? So your poop is brown and your pee is yellow and your bruises change color because of this recycling of the heme out of the hemoglobin back to the bone marrow, and that the remainder of that large organic molecule becomes these colored molecules. And then the odor of your feces comes from the bacterial metabolism of the foods that they actually can metabolize. So we're done with it. We've gotten everything out of it that we can. So now the bacteria get like a buffet of things. And so they break down and produce ammonia, indole, scatol, and hydrogen sulfide, which are aromatic components that give poop its aroma. Ugh, right? Poop stinks. And that's why. Bacteria, we can thank them for that, and flatulence, farts and stuff. Okay, so when the small intestine peristalsis, it peristalsis pretty continually with the stimulation from the stomach, the gastroenteric reflex and the gastroileal reflex. The large intestine peristalsis more slowly, and these are called mass movements. And so it contracts and moves this stuff slowly through your intestinal tract for the purpose of reabsorbing water. We want to make sure that we give enough time for the water to be reclaimed. Otherwise, we have to continually drink way more water than we actually need to. So we're reclaiming water back into our bloodstream in the large intestine. Now, if you've ever experienced diarrhea or constipation, those are the results of an out of balance peristalsis of the large intestine. So if you have diarrhea, what's happening is the peristalsis is moving too quickly, and your fecal matter is not staying in your intestines long enough to absorb water. And so what happens is you're pooping out watery stools, and that is the consistency of what goes into the large intestine, but it has not had time for that water to be reabsorbed. On the other end of that spectrum, if the peristalsis is too slow, a lot extra water gets taken out, and what you end up with is hard, compact stools, which are hard to pass, and this is what we call constipation. And that could be some natural things, it could be dietary related. Some medications can cause constipation, hormones can cause constipation, like pregnancy can go in either direction. So an imbalance in the peristalsis of your large intestine could lead to either loose stools of like diarrhea or compact and hard stools like constipation. Yes, okay. So then the last slide that we're going to take a look at the actual process of pooping, defecation reflex. And I will have to tell you, I would share this with you in class. So as a full-time instructor, we get evaluated every 5 years. And so a couple years ago was my 5-year evaluation, and the dean says, okay, so these are the times that I'm available. What lectures are you going to do? So I'm like, I gave him some list of dates that he could come and sit in my lecture, and this was the lecture that he came and sat in on. So I'm like, great, I have to do my intensive evaluation with the dean of the science department on pooping. Yeah, I did a good job. He liked it. Learned a lot. It was fun. Okay, so this is a defecation reflex. This is one of our positive feedback mechanisms. So we've got a lot of examples of negative feedback under our belt. This is one of our positive feedback. So remember, we had bleeding, or the platelet plug was a positive feedback mechanism. Defecation is a positive feedback mechanism, and urination, when we get to that in chapter 26, it is also positive feedback. Those are the 3 examples of positive feedback. So here's our defecation reflex. All right, so let's say things are progressing normally through your large intestine. We're not super fast, we're not super slow, so things are going right along regularly, right? So let's start with step 1. So as your peristalsis, these mass movements are happening, the fecal matter is making its way down towards past the sigmoid colon down into the rectum. And so this is going to be our first step, right? So stretch receptors. So stretch receptors, the wall of the rectum is now getting extended because of this incoming solid waste. So this triggers two paths. We're going to do the short reflex first and then the long reflex. So in the short reflex, step 2 here, what that does is it stimulates the myenteric plexus because we still have that. It's just modified a little bit in the large intestine, and that triggers muscular contractions of just the sigmoid colon. Okay, so that increases local peristalsis. So it's pushing more and more feces down into your rectum, and so that's going to distend the rectum, triggering the stretch receptors, and so here we get our little short reflex feedback loop. So this is our positive loop just in the sigmoid colon. Okay, so that's happening in the last maybe like 12 inches of your large intestine. So then if we go back here, step 2A here, so that again, that original distension is going to go and stimulate parasympathetic motor neurons in the sacral spinal cord, right? Cranial sacral is our parasympathetic house, kind of origin of our preganglionic neurons. So a couple of things are going to happen with this step 2A. One, we will cause an inhibition of, or I should do this, right? The inhibition of the internal anal sphincter. So that's going to relax. There's two anal sphincters. The internal is smooth muscle. The external is skeletal muscle. So this 2A comes down and it relaxes the internal sphincter, allowing the feces to move down towards the anus, kind of putting pressure on the external anal sphincter. And then what that also does is in the somatic pathway, because now it's gone up to your spinal cord up here in the long reflex, right? Long reflexes go up to your CNS. It is going to give you that sensation of, okay, stuff's moving down there. So now we are going to do the somatic control of your external anal sphincter. So that gives you control over defecation. Now in babies, they don't have this descending path yet, so they cannot control it. That's why they wear diapers. As you age, elderly and senile individuals may also lose that ability to contract their external anal sphincter, and so they lose control. Also, if you are paralyzed, if you have spinal cord damage and you cannot send that signal, ascending or descending signals, this pathway will not function. It stays closed, but then as the pressure builds, it will automatically open up. And so people who are paralyzed, they can defecate, they just cannot control when they defecate. Okay, so now we have the internal anal sphincter open, the external anal sphincter closed, and we, in our long reflex, we can continue to increase peristalsis throughout the entire large intestine, right? Because these long reflexes are more organ-wide. So we have short reflexes stimulating just the sigmoid colon. We have long reflexes stimulating peristalsis along the entire large intestine. And eventually the pressure will build up so much that you're like, oh, okay, I got to make a run to the bathroom. And then you consciously can open up your external anal sphincter, and then out comes your feces, and then you're done. And then that is defecation. All right, there you go. Wasn't that fun? That's not too hard. Okay, so that's it. That's it for the large intestine. Not too much. This is kind of a short video. The next one I will be making, I have a couple more. We're going to do one, I'm comboing the pancreas and the liver, which are and gallbladder, which are the accessory structures to the digestive system. And then I'll do a final one on absorption, kind of putting all the pieces together, and hormonal regulation. All right, I'll see you next time. Bye.